Today we are discussing about kinematics from grade 11. Before that, subscribe, share and like our video. Let's continue the topic. Motion along a straight line. Motion along a straight line classified into two classes. These are uniform motion and uniform accelerated motion. First one, a uniform motion, and the second classification of motion along a straight line is uniform accelerated motion. The first one, a uniform motion, it is a motion with a constant velocity, and the second one, uniform accelerated motion, it is a motion with constant or steady acceleration. So when a body moving equal interval of displacement with equal interval of time, then velocity constant, such motion is a uniform motion. This is when a body or an object covers equal distance with equal interval of time, then velocity constant or speed, since it is distance, speed constant, such motion is said to be a uniform motion. When velocity constant. And the second classification of motion along a straight line is uniform accelerated motion, and this is when equal change in velocity with equal interval of time, then acceleration constant or steady, such motion is uniform accelerated motion. Now let's start from a uniform motion. First, let's see terms that describe a uniform motion, like distance, displacement, speed, velocity. First, distance. It is a total path length between 2 points or place. Between 2 pointers or places, it is a distance, and distance is denoted by letter X. We can use S, we can use Y to represent the distance. The distance is a scalar quantity, which means it has only magnitude. It is a scalar quantity. A distance is measured with a units of distance. It can be meter, kilometer, mile, inch, centimeter, millimeter, so and so. From this, meter is the SI unit of distance. SI unit of distance. Distance depends on the path followed by a moving body. It depends on path followed by a body, and distance always positive. It is always positive because it is a scalar quantity. Scalar quantities are quantities which have only magnitude. Magnitude cannot be negative. Therefore, distance always a positive. The second one, which is displacement. A displacement, it is a distance in a particular or specified direction. Particular direction. Distance in a particular direction. It is a vector quantity. Vector quantity. It's represented by using X with bar to represent a vector, S with a bar to represent a vector. The unit of displacement, which is the same as a distance, has the same unit as distance, has the same unit as distance. It depends on the direction. It is independent of us, but it depends on the direction. Since displacement vector, it can be positive, it can be positive, 0, or it can be negative. And distance or displacement always less than or equal to distance. Displacement is always less than or equal to, but it is not greater than that of distance. For example, if we take point A and this is point B, a body or an object can move along path 1, or it can move along path 2, but the displacement is from point A to point B, shortest path in a particular direction. This is path 3. Therefore, path 3 is displacement, and path 1 and path 2, path 1 and path 2 are examples of distance, while path 2 is a displacement. it is displacement. Therefore, displacement delta x equals displacement at a final time, which is t2, minus displacement at initial time, which is t1. Displacement equals change in a final position minus change displacement at the initial time. This is the end for today. Next, we'll continue speed, velocity, and instantaneous velocity. Also, we may see graph of uniform motion. Bye.